Welcome to CCNA 2 Chapter 7 Access Control Lists. This is going to be another one of those chapters where you are going to be very happy that you were not in CCNA 2 last year, because really the most or second most complicated part of this section has been pushed to CCNA 3 and 4. So still not the easiest topic in the world. But we don't have to do what are called extended access control lists anymore. We only have to know how to configure standard, which are a lot simpler. So the toughest thing we'll probably see in this chapter is possibly the wildcard mask. That can be a little hard to get wrap your head around, because if you don't understand subnetting that well, then wildcard masks are also going to prove to be a little bit of a problem. So we'll go over the wildcard mask, we'll go over the access control list, what they are, what they do, as we, go through the chapter. So let's get started with access control list operation. This is where access control lists are where you can block specific users, specific networks from accessing a website, accessing a protocol, accessing this, that, or the other. So you can permit or deny traffic as you see fit. You have a lot more options with extended access control lists, but with standard you can just block an IP address from getting to such and such network. Okay, so by default there's no access control list in place. Everyone on the network can access whatever, or at least attempt to access whatever they need to. Okay, but with access control lists we could allow email and deny telnet. We could allow video for certain users, deny video for other users. Okay, so you can create basically a bunch of permit or deny statements that will, do just that, permit or deny traffic on your network, depending on how you want to set it up. Do you not want a certain group to be able to access Facebook or to be able to access YouTube or Amazon? You don't want them wasting time on the job or while in class. That's what access control lists will do, and that's what we're setting up in this chapter. So these access control lists are going to use packet filtering, which is going to filter your traffic, or filter your traffic based on the contents of packets that are moving across your network. There will be criteria such as the source IP, destination IP, and protocol or port carried within the packet. So based on those things, if there's a match, you can either choose to permit traffic or deny traffic. Maybe you only want to permit traffic from a certain host, so you could permit one source IP address and deny all the others. Okay, or maybe you want to deny a certain host, so you deny that host or that network and permit all the others. Those are rules you can set up with your access control lists. Okay, and they are a list. One particular or one single permit or deny statement would be known as an access control entry, okay, an ACE. Multiple access control entries make up your access control lists. And you'll see how we create these entries in just a minute here. Alright, so these access control lists can be applied on either an inbound port or interface or an outbound interface. Okay, and there's reason why you'd use one versus the other. The inbound, if you apply a access control list on an inbound interface, the router will make a decision based on packet filtering before it looks up the destination in the routing table, and then go ahead and decide to permit or deny traffic. So if you have a inbound access control list, you can save your router from having to do that lookup and wasting CPU cycles and the processor on the router in order to drop that packet before it ever gets looked up in the routing table. That's going to save you a little bit of time, free up your router to do other things. So hopefully the intention is to overall increase your network speed. So there will be situations where you'll want to use the inbound. If you're using an outbound, then it's already going to have gone through the routing process and be ready to be pushed out of the router. Okay. So for instance, maybe you have a PC over here who and two other networks on this side of the router. Okay. One network is another classroom, we'll say. Another network is a school server that only faculty maybe should have access to. If you place an outbound ACL, you can apply it just for that server, and this PC over here would not be able to access this server. If you applied it on the inbound, okay, denying traffic from this network, then well, it's not going to be able to reach either one. Okay, so there will be situations where you want to use the outbound and you want to use the inbound. Okay, and we'll talk about where you place these access control lists later on in this presentation as well. There are reasons to place your access control list in one place or another. So here we have our first complicated topic, which is wildcard masking that you use when creating your access control lists. You do need a mask along with your IP address when you're going to apply an access control list to a certain IP address or a certain network. Okay, so what we're going to do is have this wildcard mask, and to keep it as simple as possible, a wildcard mask is the opposite of a subnet mask. Okay, in a subnet mask, all of your ones are considered matching bits for a network. Okay, the opposite is true for a wildcard mask, where all your zeros would be considered matching bits. So, for instance, you can see this table here where you have all matches with all zeros. Only the first two are matches here. First four, so on and so forth. So basically you want zeros. Zeros are your matching bits in a wildcard mask rather than ones. They're the opposite of a subnet mask. So for instance, in this situation where we have a IP address of 192.168.10.0, okay, if we had a 255.255.00, we would match exactly as you see down here, 192.168.00. But with the wildcard mask, you see it's a 00255.255, which is exactly the opposite. All right. So that might make your head hurt a little because we're basically flipping things around and doing an opposite. What we would do in wildcard masking, I'm sorry, not wildcard, in subnet masking, we would take any time where we match a 1 and drop it down, right? That's what we did in subnet mask. Anytime a 1 matches, we drop it down. Anything else is a 0. Okay? In your wildcard mask, any 0 down here that matches a 1 up top will be dropped down. Anything else will be a 0. Okay? So I've got a 0 and a 1 here, the 1 drops down. 0 and a 1 there, the 1 drops down. Doesn't matter if I have a 1 up here and a 0 down here. I'm sorry. It doesn't matter if I have a 0 up here and a 1 down there. That doesn't matter. It always has to be a 1 up top, 0 at the bottom. Okay, 1 up top, 0 at the bottom in the wildcard mask. So for instance here, we have a 0 and a 1. Alright, that does not become a 1. It's still a 0. Okay, just like in subnet masking, you had to match you could only match one way. If there's 2 1s, then it drops down. Wildcard mask is a little different in that it has to be a 0 in the wildcard mask, 1 up top, and then it drops down. Okay, if it's a 0 up top, 1 in the wildcard mask, that does not drop down. Okay. We won't have to do this very often. Hopefully we don't have to do it at all because there is a shortcut. But the basic concept is that a wildcard mask is exactly the opposite of a subnet mask. Okay. In fact, here's a shortcut way to get your wildcard mask. You can take your subnet mask. Take your subnet mask here. Take 255, 255, 255, 255, subtract whatever your subnet mask is, and that is going to give you a wildcard mask. And that's probably the easiest way to do it. Okay? So you're going to take 255, 255, 255, 255, subtract your subnet mask of 255, 255, 255, 240, okay? And the wildcard mask becomes 0s, 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 15, and there you go. Okay. Same thing down here. Subtract your subnet mask, you get your wildcard mask. They're exactly opposite of each other. To illustrate that one more time, I'm going to go here in a subnet mask. If you had all 0 bits, okay, that would cover an entire network or any address whatsoever. Okay, any address whatsoever. In a wildcard mask, all zeros is the equivalent of all 255s, or just one address. Okay, just one address. This is all matching. Okay, and you'd use this to match just one host, all zeros in a wildcard mask, whereas in a subnet mask, all zeros would match every address in the network, every address possible. Here it's just one. And the opposite's true. In a wildcard mask, if you have 255, 255, 255, 255, that's the equivalent of a 0000 subnet mask, which means it matches anything. Okay, it covers the entire network. All right, so that's what you get there in your subnet mask. All right, so for one host, you would use all zeros. If you're trying to eliminate just one host in a access control list with your wildcard mask. If you want to cover all hosts, then you'd use this 255, 255, 255, 255. That represents any host. Okay. All right, so all in all, wildcard mask, opposite subnet mask. The other thing you're going to want to know, there's just one more thing. You will need to be able to identify your block size for your networks. Okay. Just like you need to identify your block size for by looking at a subnet mask. All right. You need to be able to identify your block size with a wildcard mask, and here's how you're going to be able to do it. All right. So I'm going to go ahead and come back up to this slide. So we have a wildcard mask here of 00, 15, 255, correct? If I were to turn that into a subnet mask, that would be 255, 255, 240, because, well, 255 minus 15 is 240. All right, 240, 0. All right, 255, 255, 240, 0. Is what my subnet mask would be. So if I have that 240 in the third octet where I'm working, okay, 240 is, let's bring our subnet chart over. I'm not going to spend too much time on this because we've already gone over subnetting and I don't want to overload you again. But so I've got borrowed bit, borrowed bit, borrowed bit, borrowed bit. We're at the 16, okay, for 240. 128 plus 64 plus 32 plus 16 is 240. Our block size is 16. Our block size is 16. We can see that here. Okay, and we've also gone over a technique that if you want to know, once you have your bits borrowed here, what the value is of your, the decimal value is in your subnet mask for this bit, you can take 256 minus this number, and we get that 240 that appears in our subnet mask. Remember, we just said our subnet mask was going to be 255.240. I'm sorry, 255.255.240.0. Looking at the previous example. Okay, so our block size is 16. If we took 256 minus 16, we'd get that 240 that shows up in the subnet mask. All right. Hopefully, you're following me with this. I'm just saying all this to make sense out of the fact that in your wildcard mask, because your wildcard mask is already 255 minus your subnet mask, if 256, whoops, this thing's sliding around. If 256 minus your subnet mask gives you the block size, okay, then, well, 255 minus your subnet mask should give you close to your block size. It's your block size minus 1. So if you see this number 15 here, you can take that 15 plus 1. You know your block size is 16. Okay, so your block sizes in subnet masking really a lot easier. I'm sorry, in wildcard masking. Your block sizes in wildcard masking are a lot easier. You can just take the octet you're working in plus 1, that is your block size. So for instance, the resulting range of this wildcard mask is 16 through 31. Okay, it's 16. It's 16 because we take this number plus 1, that will give you your block size, which is kind of easy. It's kind of easy. So just think of it that way. That technique will work. I'm not going to spend too much time on it, but yes, this plus 1, all right, that's your block size. That is your block size. See if I can find a different example here. So down here we've got 255.255.252, okay, .0.0, which gives us a, this is our subnet mask, remember, which gives us a 003.255. Well, if we borrow bits out to 252, ooh, this thing is really sliding around on me for some reason. If we borrow bits out to 252, that would be placing a 1 here and a 1 there. Okay, that takes us to the 252 spot. Look at our block size, it's 4. Okay, if you add these up, you will get 252. I'm just going to minimize that because I'm not coming back to it. Here's our 3 down here. 3 plus 1 is 4. That is your block size. So again, you can take whichever octet you're working in, increase that value by 1. That is going to be your block size. Okay, so know that it's really easier than subnet masking when trying to figure out your block size. Less math involved. Just add 1. You got it. Okay. So that's something you might be asked to do by looking at a subnet wildcard mask. You might be asked to give the range of the network based on the wildcard mask, and you can see, okay, it's going to be block size of 4, so I'll just take the network and know that's my block size, and I can figure out the range based on that. Okay. All right, moving on. So if there are any other questions about wildcard masking, just bring them up in class. We can discuss it more. But at a base level, just take your subnet mask, take 255, 255, 255, 255, subtract your subnet mask, you'll get your wildcard mask. Okay. All right, so here, talked about how your wildcard mask is, of course, reverse. So a 255, 255, 255, 255 would be equal to a quad 0 in terms of subnet masking. So if we wanted to create an access list that permits everything, okay, it just permits everything. Remember in our routing tables, we would create a default static route of quad 0 to catch any traffic. That's the same thing that you see here. It's a quad 0 with a wildcard mask of all 255s, which basically is like another quad 0 because it's the opposite of a subnet mask. So this access list would permit anything, covers all IP addresses, okay, just like your quad 0 would. Down here, if you only want to permit a specific host, okay, it's the opposite situation. Oh, I'm sorry, the other the other part of this is that when you're creating your access list, if you don't want to have to write out this quad 0, 255, 255, 255, you can just write out any in its place, and that's going to shorten the process for you. Okay, so that permits any IP address. If you just type in any or this, it's exactly the same. So once you get used to it, you might as well just type any because that's going to be shorter. All right. And down here, the opposite. You've got permitting 192.168.10.10. You would only want to permit that one single IP address. So you have a 0000 out here as your wildcard, again, which would be equal to a 255.255.255.255 subnet mask, which would give you just one host. Okay, so if you don't want to have to write out this quad 0 wildcard mask, you can write in access list permit host, then whatever that host IP address is, and you don't have to write out this wildcard mask at the end. Okay, so those are some shortcut keywords that you can use. You don't have to, you can, it's an option, and it's probably going to make things a little faster as you configure your devices to use either any or host. Okay, so there's your keyword examples here. They were explained on the previous slide, but I kind of just used this previous slide to give you an example of wildcard mask versus subnet mask. But yeah, here's where the concept was introduced of using host instead, or using any instead of using your wildcard. Okay, I know we're introducing a lot of concepts and we haven't gone through the commands yet. We will in just a second. So here we have some general guidelines for creating your ACLs. You can see the rules down here, which are you have one ACL per protocol, per direction, per interface. So what that means is, well, let's say we have, I don't know, one interface over here. Okay, you can have a access control list for IPv4. Let me see how I want to word this. You can have an access control list on one port for IPv4 inbound and IPv4 outbound on that same port. Let's say we just have one port over here. You can also have an access control list for IPv6 inbound and IPv6 outbound. All right, for a total of 4, I guess, per port is how many access control lists. So 2 for IPv4, 1 inbound, 1 outbound. 2 for IPv6, 1 inbound, 1 outbound. That's all you can have per interface. Okay, so that's going to be somewhat important, I guess. You'll probably see a test question or two on that. All right, so if you had 2 interfaces, like they say on this router, you would have a total of 8. One interface would be a total of 4. Again, 1 per protocol and 1 inbound, 1 outbound. Okay, that's a total of 4 that you get there. So more best practices, base your ACLs on the security policy of your organization. So you meet organizational guidelines, prepare a description of what you want to do. You can even make description remarks in your access control list once you start doing extended ones, which we don't happen to cover in this course. You can use a text editor. We saw last class how you can use Notepad to create shortcuts for yourself. If you're going to create access control lists and have access control entries that you want to have as reusable, you could save them to some type of text file and just, paste them in like we did last week with our, what did we do that for? VLANs, with our VLANs that we did last week. Text your access control lists on a development network before you implement them on a network, production network. You don't want to implement your access control lists in the middle of a heavy flow work day, and then all of a sudden something goes wrong and you have a million phone calls coming in, people trying to get to this or that website, access this or that protocol or email, whatever. You want to probably apply it you definitely want to apply it in a test environment first, or maybe off hours, and test it yourself before implementing it into or on a production network, because things could go wrong. You never know. So those are your best practices. Here we have a slide on where you want to place your access control lists. And then, as I've stated before, we don't do extended access control lists, but those extended access control lists are typically placed near the source, and standard are typically placed near the destination. And here's basically why. Your standard access control lists filter based on source IP only. Okay, it doesn't filter based on a specific protocol or port number or anything like that. You're just basically blocking all traffic from a source IP address. Okay, so let's say you got your source here, and you got your destination. All right, I want to block this source or this IP address, maybe the whole network, from reaching, let's say, PC3. We want the PC1 to be able to communicate with the server over here, but we don't want to be able to communicate with PC3. If I, well, place a deny statement or deny statement in my access control list over here closest to the source, well, you're denied access to anywhere, essentially. Okay, you're not going anywhere but within the local network because you've denied access to this source IP address. If you place it closest to the destination, let's say I want to block it from PC3, I place that access control list outbound for G00 here, meaning that only network that a PC1 can access is the network with PC3 on it. Okay, and I've done my job. I can still get to the server. I'm still good to go. All right. If I had the same type of situation come up, and well, I have an extended access control list. Okay. Here's why I want to place it closer to the source, because I can kill unnecessary traffic before it's routed through R1, before it's routed through R2, before it's routed through R3. I'm taking up unnecessary bandwidth if I'm trying to communicate with PC3, and that's just going to be killed anyway. If I can kill it earlier than later, then that makes my network more efficient. Okay, so I can place an extended access control list. An extended access control list can filter based on source IP, destination IP, protocol, port number. So for my extended access control list, I can place it right here before it even gets routed on R1. I can do an inbound access control list on G00 saying any traffic with a source IP address from this network and a destination IP address to this network, I'm going to deny. Okay, that's what I'm going to do. So I can place that right here. I've done my job. Anything headed for this network is not going to make it. And I haven't had to forward it out R1 to R2 to R3 before that decision gets made. I've freed up my network a little bit. Everything's running more efficiently. So extended access control lists will allow you to do that. Standard will not. So that's why you'd place extended typically closer to the source. You don't need to have any unnecessary traffic traveling over your network. Your standard closer to the destination, because you don't want to block access to something you don't mean to block access to. Okay. Okay, so there it is restated. Placement of your access control list: extended to the source, standard, destination. I don't know how you really want to remember that, but yeah, extended to the source, standard to the destination. Okay. And here we have just another example, standard access control list placement. So you want it closest to the destination. This is pretty much the exact same thing I just said. But if you placed it before it got to R3, R3 would be, well, any network attached to R3 would be inaccessible from over on the left side in this 10 network. If you place it in the outbound of R3 towards network 30 here, then you've only denied access to this network, which is probably what you intended. You still can communicate with the 31 network here, and you're all good. So again, closest to the destination for your standard access control list placement. And those rules for access control lists, the standard ones, are going to be most important to us because we are going to configure standard. We are not going to configure extended. Okay, now we're going to talk about actually creating these access control lists. Only standard, like I mentioned before. We don't have to do extended anymore, which, again, we're a lot more complicated. Standard's still not super easy, but not so bad. So the first thing we have is a numbered IPv4 access control list. Your numbered list, I'm not sure that's the way you'll want to go about making them most of the time. Named lists really, I think, make the process a bit faster. So anyway, the numbered list you're going to have to know how to make anyway. And how you're going to, well, make that is with this access list command. You're going to number that list, whatever number you want it to be. Okay. So we have access list 10 here. And then you're going to state what you want to do. Do you want to permit traffic? Do you want to deny traffic? Or do you want to make a remark? Okay. A remark is just going to be a note to yourself that you typically place to remind yourself when you look at your running config what you created this access list for. It might not be always that apparent that this access list is to permit hosts from the yada yada network. Okay, when you place this remark in here, you do your show running config, and in this access list, it's going to tell you what your intention was when creating this list. Okay, so we have the first access control list entry up here, access list 10, permit the 192.168.10.0 network. And again, there's a wildcard mask, which is 000.255. Again, we can flip that if you want to think about it like a subnet. It's 255.255.255.0 instead. So you're permitting the 192.168.10.0 network. All right, that's what this entry would do if you left it unaltered. Now, you might ask yourself, why am I just permitting this network? What does that do for me if I just permit it? There is something called an implicit deny message at the end of each one of your access list statements that you don't even have to type in. If you make any kind of access list, the last entry without you typing anything in, or the last thing that happens, is it denies everything else that you don't mention in this list. So if you've permitted just this network, this statement will permit this network only, then deny everything else at the end. Okay, so that's that implicit deny at the end of your access list. So again, this access list entry would permit this network and deny everything else. Okay, we can also go in here, we'll go no access list if you want to remove that access list. All right. If you did a show access list, you can see that access list here. It's going to permit yada yada, wildcard bits here. And then, okay, if you wanted to remove it, no access list, like we were saying. All right. If you wanted to create it again, here's a different way to do it with the remark. Okay, so access list 10, you're going to make the remark that this is going to permit hosts from said network 192.168.10.0. And then you're going to actually make the entry for the permit. Okay, the permit statement. So access list 10, permit, blah, blah, blah. Same permit we made up here. It's just now we're going to have this remark in there. Okay, and we do a show running config include access list 10. We can see those things here. There's the remark. There's the entry remade. So that's a very, very simple access list. Okay. This slide is going to show us how we would apply that access list to an interface. So we'd make the access list first. In this case, we're making access list 1, permit, same network we're permitting here. Okay, so we make the access list. Then we go to the interface we want to apply the access list to, 0.0.0.0 in this situation. And which direction do we want to apply it to on the interface? Do you want to apply it to outbound traffic or inbound traffic? Okay, so IP access -group, out or in. We're going to choose out here. Okay, so that's how you do it. Just IP access group, whichever access list you want to use, and then inbound or outbound on that interface. Remember that standard access lists can only be applied to source IP addresses, and typically for a standard access list, you want to put that access list as close to the destination as possible, whereas with an extended access list, you'd want to place it as close to the source as possible. So what we would have done here if we had created this access list in the current topology is we permitted the 10 network over here. It can go ahead and go out because we permitted it. Everything else would be denied. So the 11 network over here, the network attached to G01, is not going to be allowed out that way. It will be denied. that access. Okay, if there was another network over here though, it could reach it. It just can't go out serial 0, 0, 0. All right, and we did pretty much place the list closest to the destination. I don't know what else is over here, but as far as our equipment is concerned, our topology, we did place the access list closest to the destination as possible. Here we have an example where we want to deny a specific host in a network. Okay. So first, we've got no access list 1. That's going to remove the access list. That removes it from the access list entries. There's no access list anymore, so we'll have to reassign it to the interface again, as you'll see down here for serial 0, 0, 0. All right. So we erase the access list. We've got access list 1 we're creating again after erasing it. In this situation, we're going to deny the host. Okay. And if you're going to make multiple, which you typically will, make multiple access list entries for one access list. Okay. You want to make your host statements come first, your host entries come first, then your network entries, because if you don't, the device is going to rearrange them that way anyway. The device lists host access list entries first, and then network range access list entries second, okay, or network second. You'll see that in a troubleshooting slide that we have a little further down the list. Okay, so we deny this host, all right, and then we permit everything else from the network. Also, remember there's an implicit deny at the end, which means, well, we're going to permit everything in this network but this host and deny basically everything else. Okay, because at the end we don't have to type it in, but there's a deny any statement. Deny anything. Okay, so that's what we got here. Then we go back to the interface access group 1, IP access group 1, outbound, same place we put it before. And in this situation, we've denied PC1, but anything else in this network, we'll just use your imagination. And imagine there's some other things in this network, and they would be able to communicate out serial 0, 0. Here we have a situation where our intention would be in this situation not to let PC1 communicate anywhere outside of the local network over here. Okay, so we just want to deny it the ability to get to the router and get off the network. Okay, so in this situation, the previous situation, PC1 could still communicate with anything else that wasn't out serial 0, 0. It could communicate with this network over here. Okay, the 11 network. But in our current situation, we don't even want it communicating with the 11 network. We don't want it communicating anywhere. So we would, again, no access list 1, removing that access list that we had just made. Access list 1, deny the host, still the same thing we wrote before, deny host, blah, 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 which is PC1. Okay. And because we wrote host in here, we don't have to have a wildcard mask. Remember that. Host is as good as having a wildcard mask of 0, 0, 0, 0. 0, 0, 0, 0. Yes, that's 4 zeros. So we don't need to write out the wildcard mask over here. And we're permitting anything else. So anything else from within this network, yes, can get out. But host 1010 is not going to be able to. We apply it to the gigabit 00, okay, and that's an inbound access list that we'd be creating, blocking PC1. Okay, all right, so that's a little bit on numbered access lists. We have named. Next. So named access lists, if you're going to have a multiple entry list, is going to be the way to go. It's going to save you time because you don't have to type in access list some number over and over and over again. You just have to create the access list name by typing in IP access list. We're using standard only in this situation, or in our class I should say. So we type in IP access list standard, then the name of the access list. After pressing enter, then you would go ahead and you'll see your prompt here change to config standard named access list. And you start making your permit, deny, remark entries in that access list. Okay, you still apply the access group the same. It's just instead of using a group number, you would use a group name. So let's take a look at how that's going to be a bit different. So here we have the creation of IP access list standard, and the name will be no access. Okay, no access. We are now going to type in deny host blah permit any. Instead of having to type in access list 10 deny host yada yada, access list 10 permit any, we don't have to type that anymore. Okay, it knows what access list we're in. So we're just making our permit, deny, remark entries without having to type in access list over and over again, and that's going to save you some time, hopefully. So that's how named access list would work. You're just going to get into this new prompt by typing IP access list standard or extended. We're only doing standard in our class. Then the name of the access list, and you'll go ahead and make your entries, and when you're done, exit that access list. When you want to apply it, you're going to go into the interface just like you would before, type an IP access group, and instead of a number, you'll type in a name and say inbound or outbound. Okay, a couple things here before we leave this slide. Your access list name does not need to be capitalized here. You can make it all lowercase, all uppercase, mixed case, if you want to be really annoying. But it is case sensitive, so you want to make sure you use the right case, because when you type it in and try to apply it to an access group or an interface, then you need to use the same case there. It probably is a good idea to make them all capitals. They will stand out more that way in a configuration. So probably a good idea to make them all capital, just so they stand out a bit more. Also, there's no spaces in your access list names. That's why you see an underscore here. So if you need to make a space, just use an underscore, and that will suit your needs. So no spaces in your access list, and they are case sensitive. All right. So, and they can be alphanumeric. It can be numbers or letters. So we'll move on. Moving on to modifying access lists. The way you maybe don't want to do it. You can. Well, go into your show running config, copy your access list, paste it into a text editor, okay, and then you could go in and remove the access list, go to your text editor, copy it, then paste it in with your corrections, and you'd go from there. Okay, sounds like a lot of work, because it kind of is. So there is a different technique you can use after you make your access list. If you do a show access list, you'll see the number your access list is given. You don't have to create that number yourself. It's something that happens automatically. So for instance, we have 10 deny blah blah blah, 20 permit blah blah blah. Okay, that is created automatically for you. If we go in and we edit your access list by name. So when we created the access list, we just did access list 1 blah, access list 2 blah, out there. Okay, we didn't use a named access list, but it still has the name 1. Okay, that's its name. So we can go back in and type in IP access dash list standard 1. Okay, that's where the name would be, and the name is 1, so we can get into that list. And once we're into that that prompt for a standard access list, standard named access list, I should say, we can say we don't want any 10, so go no 10, 10's gone. Okay, then we can create a new 10, deny host, this host instead, and we're good to go. All right, so we have that there. Then if we go to show access list again, you'll see your new entry there. So you can remove that numbered list. Alright, so also if you wanted to make another entry between those two, you can see they give you some room between 10 and 20. Hopefully you don't need to make 9 edits in between them, or more than 9, because, well, it's going to be tough. But if you created an initial access list and you noticed that, okay, I needed to put in something else between the two, just use a numbering scheme to place one between the two, or before 10, or whatever number you need. In this situation, we have a need to deny another host. We denied the 10 host. We needed to deny the 11 host as well. Okay, so we'll go back into that named list. All right, type in the number that comes between the two, any number. It could be 15, 12, whatever, and make your entry. And that entry will appear between these two access list entries. Okay, access lists are read from top to bottom. Okay, and as soon as a match is found in an access list, it stops. It doesn't go through the whole list like a routing table. As soon as a match is found, it stops. Okay, which is why you need to create things this way, kind of. If you had this permit network 192.168.11.0 up top, it would see that, and if there's a match which covers 192.168.11.10, it would just stop there and permit everything. It would never make it down to these deny entries here. Okay, it would never make it to the deny entries. That's why we need these deny entries first, so it can see to deny 10, then deny 11, and permit everything else. Okay, again, if this permit was up top, it would permit everything, and it would never even look beneath that. It would see that the traffic is a match for this permit entry, and so it would stop looking through your access lists. All right, so that's how access lists are looked through. It looks for a match. As soon as it finds a match, it's going to stop looking from top to bottom. Okay. Verifying, we can do show IP interfaces and see that your outgoing access list is blank. It's there. I don't mean it's blank. I mean it is listed as 1. We can do a show IP interfaces for a named access list. That name will come up. You also have a show access list, which will show you the list that you have created. So you can verify which interfaces it's on, verify what the list is and how it was created, and you can see that all there. Okay, so that's what we have here. All right, let me go back one slide. You may have noticed here that you've got a 15 before your 10 here. Okay, that's because the iOS will reorder your host access list entries using a special hashing function. Basically, it'll go ahead and do what it needs to based on this hashing function to make it so that it can process these entries as efficiently as possible. So your host entries can be rearranged on you. Okay, you should always have your denies and permits together, but your host entries can be rearranged on you. Your network entries will not be. So whatever order you put your network entries in, they'll stay in there. But your host entries in your access control lists can be rearranged. So that's something to be aware of. Let's see what else we got here. When you're looking at your show access list, you can see how many matches you have for a deny or permit. Okay, so it shows you your matches here. You can see that this person is trying to do things they shouldn't be, so that might be something you want to look into. All right, it gets even more specific when you use extended range, extended access control lists, in that you can see exactly what protocol they're trying to access they shouldn't be trying to access. All right. And if you use the command clear access list counters for a certain access list, you can clear out that counter for matches. Alright, so you've got that here. So we only did it for one. We have a couple matches for this named entry, no access, 4 matches there. Haven't done it for that that no access control list. Maybe we should just call them ACLs. That no access ACL has not been cleared, so it still has 4 matches down here. Okay. We also have something called access class. Okay, so when you're applying an access list to either SSH or I should just say your VTY lines, when you're applying your access list to VTY lines, you're going to use the access class command rather than access group. We've been using access group on your real interfaces. Okay, on a virtual interface like these VTY lines, you're going to use access class instead. So that's what you type in. The creation of the list is just the same. Okay, what do you want to permit? What do you want to deny? But when you apply it to a VTY line, you're going to use access class. Okay, so when you do that, whoever you've permitted will be presented with the ability to log in. When they try to SSH or telnet, if they weren't permitted or given that ability, then, well, connection's going to be refused. Okay, so again, that's access class that you would use, access class. All right, and that is configuring your access control list. We've got troubleshooting, then we're done. So here we go. The implicit deny at the end of your access list. Okay, I mentioned this before. You have an implicit deny, denies any other traffic at the end of your list. And here's how they're going to give you an example for that. When you make an access list entry that says permit IP this network range, 192.168.10.0, we're going to permit that network. When you make that entry, access control or access list 1 or ACL 1 is going to permit that network and deny everything else. It would be the same as writing this in. Access list, permit that network, then deny anything. It's the exact same thing. Okay, it will have the exact same effect. We don't need to write in this implicit deny. It is there already. We don't need to worry about it ourselves. Okay, so again, in any access list, this deny any is already automatically entered in the bottom. Why that's very important is if you just try to make an access list that denies one device and you don't permit anything, everything's going to be denied. Okay, so you need to have some type of permit. Otherwise, you're denying all traffic in an access list. Okay. So a general rule is your host statement should go before your network statements. In this specific scenario, in fact, we talked about this example a little bit ago as well, that if you deny this entire network, okay, then try to permit a host from that network, it's going to look at this deny the whole network entry and never get to the host part. It looks for the first match, sees it, and then it's done looking for access control list entries. Okay, so as soon as there's a match, it'll say deny. All right, I'm denying. Doesn't matter. I don't know that there's a permit host entry down here. I don't care. I found a match. It said deny, so I'm denying. So what you need to do instead is make your host entry first, and then deny the network afterwards. That way, if the host comes in trying to get access, it'll say, okay, I got a match. It says permit, good. Anything that doesn't match the host, well, it'll drop down and find that deny entry, and you'll be good to go there. Okay, so that is very important. So here you see that you can configure a host statement after a range statement if there is no conflict. You can, if you want. But typically your host statements are rearranged before your network statements anyway, so you should be fine Should be fine either way. So what will be a little different is that your running config is not going to show what you think it will perhaps when it shows you your access list. Okay. In this example here, we have the creation of your access list. Access list 1, deny, 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 network ranges. Okay, then you have a bunch of host entries, which is fine because these hosts don't conflict with the network statements up here, or network entries I should say. If they did, then you'd get an error message, okay, like we saw in the previous example back there. When you do a show running config, you'll see all of your host entries are first, and then your network entries or network range entries are second. That's just the way that your router is going to look through these access control lists. Okay, so it reads hosts first, reads network ranges second. As we go down, we can see that even though we entered in the host ranges in a certain order, they aren't in that order at first. Okay, there's a hash sequence that it happens, and it just helps the device search through the access control list as quickly as possible. Your network range will be listed in order, okay, but your host ranges might not. So it's always going to be host first, network or range second. Okay, but if you do copy your running configuration to your startup configuration, your host range should reorder itself. Well, at least it will reorder the numbers correctly. This sequence will change to this sequence down here. Notice that the IP addresses haven't changed. Okay, the hosts haven't changed, but the sequence numbers have. Okay, so that's just the way that the router will be able to search through these access control entries for the access control lists most efficiently. So that's why it's going to reload that way. Okay, hopefully that's clear. So hosts first, networks second. Networks will be in the order that you entered them. Hosts will not be. They'll be rearranged so that the router can look through them as quickly as possible. And if you copy your running config to startup and reload the router, it will actually change the entry numbers. Okay, so that's something you'll see as well. So here we have the routing process and ACLs. It has some general things about the routing process as it accepts a frame and checks the MAC address to see that the destination MAC address matches the router. If it does, it's going to go strip off the frame information and test that frame against the ACL and the inbound interface. Okay, if the ACL exists, if an ACL exists, it'll be tested against that packet, and if there's a match, it'll either permit or deny based on that match. Of course, if it's permitted, it's permitted. If it's denied, it's dropped. Okay, so if it's accepted, it's checked against the routing table, and they've determined a destination interface. Okay. We know that if there is no entry in the routing table for a packet, then it will be dropped. Okay. And basically it's just going to be checked against the outgoing interface if it has an ACL. If an ACL exists and it says permit, there's a permit match, then it'll encapsulate a new layer 2 frame and send it on out. If it doesn't match, then, well, it's going to be dropped. So that's pretty much what's going to happen. Accepts the frame, make sure the MAC address is okay, checks against the inbound access control list, whether it's to be permitted or denied. If it is, then it's going to look up the routing table entry, determining the outgoing interface, then it's going to test the access control list of the outgoing interface if one exists, and permit or deny based on that. Encapsulate a new layer 2 frame and send it on its way. Okay, so there's a bit that goes on. Basically, you're checking on the incoming and outgoing interfaces. So more troubleshooting. Let's take a look at what might be wrong with this. On R3, we have an access list that's going to deny all traffic from 192.168.11.10. Well, what is that access control list going to do? Not just deny the 10 network, okay, or the 10 host, I think it would be. It's going to deny everything, because remember there's that implicit deny. If you just make an access control list with one entry that says deny one item and you don't permit anything else, it will deny everything. Okay, so this list would deny everything. Instead, you'd need to make that list with a permit any after it. Then it will permit everything but this host that you're looking to deny. Okay, so again, that's an implicit deny problem. You need to remember that that is something that exists. Okay, moving on. So our other problem, we have a security policy that says the 11.0 network should not be able to access the 10.0 network. Okay, so this network, S2 network, PC2 network, should not be able to access this one over here. And we have the access control list set up correctly, but it's on R1. So we see we're in R1 here. If we apply that to an interface on R1, and we're just trying to deny access to the, we're sort of trying to deny access to the 10.0 network. Okay, that's fine. The access control list is set up fine that way. Okay, but I'm guessing the interface they apply it to is not correct. So they're going to apply it to interface gigabit Ethernet 01 inbound. So, well, that means that not only are you denying the 11.0 network access to 10.0, you're denying it access to anything. Okay, you're blocking on 01, which means it's not going to be able to pass that interface at all. Where you should apply that to is the outbound interface on G00, closest to the destination. Remember, standard access control lists are supposed to be as close to the destination as possible. So you'd want to put that on G00 here instead of inbound on G01. It would be outbound on G00, which would be correct. Okay, outbound on G00 is what you'd want. So that would take care of that. I'm guessing we'll see that in the next entry. So we go no IP access group blah on this guy. We type in IP access group blah on that guy, and we're good to go. Okay, moving on. And here it looks like we just have a basic IP addressing error. We're only supposed to allow PC1 SSH access to R1, but we made this access class with a named access list, PC1-SSH. But when we created that access list, we mistakenly put in 192.168.10.1 instead of 192.168.10.10. So to correct that, we can go back into that named access list, just go into IP access list standard, and then the name in this situation being PC1-SSH. We'll type in no 10 because 10 was the entry. Then make a new 10. 10 permit host 192.168.10.10 instead of 10.1. And we should be good to go there, and it looks like everything would be operational from that point. And that would be it. And coincidentally, that is it for Chapter 7. So again, like I was saying, it's a little lighter than it used to be. We used to have to do extended access lists. Don't have to. We just do standard now. Wildcard mask, we talked about that earlier, so that might be a little tricky at first, but it's just the reverse of a subnet mask. So we've got some situations or techniques to deal with that. We'll discuss it more in class. Hopefully this video helped for Chapter 7.